Yes, test. Let me make sure this is working. Yo. All right. Okay. Teamwork makes the dream work. Okay. All right. So, starting off, we are going to talk about probability. Probability is when they put the probability of something happening. And whatever that something is, we talk about being desired over total every single time. So for this one, we want the probability of, well, people are voting, and they're voting for either the Odoms family or 13th Night, or they didn't vote at all. So we have the Odoms family, or, so we're going to do a union, 13th Night. And when you do a union, you do kind of the U shape. So we're going to look for the Odom and 13th Night. Now, when we look at this, and you could draw what we call a Venn diagram. When you make a box, this is what they call your universe. And in your universe, you have a couple things. First off, we have the Odoms family, people that voted for them. And it said the director found that 35% voted for them. So if we turn that into a decimal, that would be 0.35. So that would be 35%. But 0.35 voted for Odoms family. Then for 13th Night, we show 57 voted for them. Now, there's also another 8% out here that didn't vote at all. So there's 8% out in the universe that didn't vote at all. So when we put all this together, anytime you talk percentages, when you add them all together, it should come out to be 100%. Okay? So with that, we're going to introduce what we call mutually exclusive. And what there is there's no overlap. Either you're going to vote for one or the other, but you cannot vote for both. Now, sometimes you can vote for both, but in this case specifically, you can only vote for one or the other. Okay? So when we do that, we're going to do the probability of each one added together. Okay? If that's the case, as long as there's no overlap, that's all we need to do. So when we do this, we can say this is our probability formula for mutually exclusive things. So the probability of O union T is we're going to take 0.35 plus 0.57, and we're going to put those together. And when we do that, we get 0.92. Now, what they're asking us, what we talk about in our classroom is you also need to make this a percentage. So we're going to take this decimal and shift it 2 places to the right. And once we do that, we're going to get 92%. And then the last thing that they also talked about and wanting to do is we want to make it a fraction. So we're going to also put 92 over 100. And once we do that, I'll pull out our Desmos calculator. 92 over 100 gives us that, which Let's see if we can simplify. No, that's not what we're looking for. 0.92. Here we go. Yep, click this button for Desmos calculator. And when we click that, you will get 23 out of 25, which is the simplified version of 92 over 100. Hey, what up, Beck? So we're going to get 23 over 25 as our simplified form of 92 over 100. So we have the decimal, we have the fraction, and we have the percent all made out for this probability problem. And remember, we called this mutually exclusive because there was no overlap with one or the other. We're going to get to some that do have overlap, but this one does not. So number 2, you can see already with this Venn diagram that we will have some overlap. Okay, this one. A restaurant noted what type of food its customers purchased last week. Here are the results. Some people ordered burgers. Some people ordered fries. Some people actually bought both. So here's what we want to look at. So when we break this down, there are burger people. Okay? The burger people actually make up the full circle of burgers. So we actually are going to look at 70% of the people ordered burgers. Then we're going to look at fries. Okay? When we do this, once again, what you want to think about is we need to highlight all of the fries. So look at that, all of the fries. Okay? And when we do that, that is 65? 10 and 55, yep, 65. Okay. Now, these are not mutually exclusive. There is an overlap. So when we do the probability of B or F, and this upside down, or this U stands for union. So it's one or the other. And when we write this equation, we're going to do the probability of B plus the probability of F. But remember, some people ordered burgers and fries at the same time. So we don't want to overlap them. So to get rid of those extras that get counted twice, we are going to take the probability of the burger and the fry, and we're going to subtract it off. So we don't want the repeats. So when we look at burgers and fries, we get 55%. And remember, all this is given information because that's what the Venn diagram tells us. So now we can use substitution to find the probability of B or F by taking the probability of B, which is 70%, and we're going to use the percents this time, so we're going to change it up just a little bit. Fries is 65%, and then we're going to subtract the intersection, which is 55%. So when you work left to right in the order of operations, we're going to do the addition first and then the subtraction, and your probability of burgers or fries is going to come out to be 80%. And if we look at 80%, we would look at it as 80.0. So now this time when we move that decimal, we're going to move it in the opposite direction. We're going to go to the left. And by doing so, that will give us the probability of burgers or fries as a decimal. Okay? And then for our fraction, percentage is always measured out of 100. So we're going to get 80 over 100, which you could cross out the zeros, and you're left with 8 over 10, which simplifies to 4 over 5. And just to double check, we would go to Desmos. We're going to put in 0.8. And if we click on this, it would give us 4/5. So we know we got the right answer. So this is where they are overlapping and are not mutually exclusive. So if they have overlap, they are not mutually exclusive. All right, number 3. Number 3 says, when registering their cars, owners must identify the color that covers the largest portion of the vehicle. In one region, the probability that the car was mainly white. So now we're going to look at the probability of mainly white is 0.24. The probability that it's mainly silver is 0.22. And the probability that it's mainly black is 0.19. Okay, this is all given information. Now we want the probability of being silver or black. So once again, when we look at this, can it fall into the silver and black category? Is there any overlap on that? And your answer, unless they tell you specifically in this word problem that there is overlap, you have to assume that there's not. Okay, so these are a mutually exclusive event. So that means we need the probability of silver plus the probability of black, and we do not need to subtract the overlap because the overlap actually is 0. There is there's none that's mainly silver and black at the same time. It's got to be one or the other. So once we do that, silver or black, we're going to plug in our probability of silver, which is 0.22, plus our probability of black, which is 0.19. And that's going to give us 41% or 0.41. And remember, if we move it 2 spots to the right, that gives us our 41%. And then if we put it over 100, 41 over 100 is that final answer. And when you think of 41, it's a prime number, so it can't really be broken down. So I know 100 is not going to be. It's going to stay at 41 over 100. Excuse me. So when we look at 41 over 100, that's 0.41. So 0.41. Oh, we could actually do it from here. 41 over 100. That's the best we get. Oh, cool. Interesting. I just found something out. So you can click this, put the fraction, or re-click it and get the decimal. That's pretty sweet. All right. On to the last one. So let's get our last poll. And we're going to look at this table. Now, this table talks about births, whether they're scheduled or not scheduled. When you start to think about this, though, you have to start thinking about mutually exclusive to overlapping. If they're overlapping, it means they share something in common. If they're not, it means that they are mutually exclusive and they are separate from each other. So if we think about this and think about it in a real life situation. So we're talking about days of birth, whether they're a scheduled birth or an unscheduled birth. So when we think about that, can someone be born on a Tuesday and also on a Saturday? And you could pick any 2 days. You can even pick Monday and Tuesday. But think about it. Is there a way where, I don't know, this is getting a little graphic, but can you, either you're being delivered on that Monday and you're fully delivered, or on that Tuesday? So when is it fully delivered? And that's as far as you can go. So these are what we call mutually exclusive events. So this is a yes. Oops. Don't have my pen. This is a yes because you can't have overlap. Either they're born on Tuesday, they're born on Friday, can't be born on both. So if I'm looking at Tuesday or Friday, I'm going to do the probability of a Tuesday plus the probability of a Friday, and that would give me one or the other. So when we look at the probability of a Tuesday, remember back at the beginning, we talked about the probability being something desired over the total. Okay? So my desired is Tuesday. Whether it's scheduled or unscheduled, we have a number that is being born on Tuesday. That is our desired. Over our total. And our total down here out of everyone is 500. Okay? Then we need the probability of a Friday. So with that same idea, same logic, we're going to do 50 over 500. Now, we can simplify these. However, I would keep the denominator the same right now before starting to try and simplify this into something that you think looks nicer. But what's the probability of a Tuesday? That was 90 over 500. Plus, the probability of a Friday is 50 over 500. And now they have a common denominator. We don't have to figure out what it is. We just have to add the numerators, which is 140 over 500. And if you've ever played this game before, you can cross out the zeros. If there's one on top and bottom, cross it out if they're at the end. And we could already simplify this to 14 over 50. And now, if we wanted to, we could divide the top and the bottom by 2 because they're both even numbers. So if we do that, we're going to get 7 over 25. And the only thing that breaks down 7 is 1 and 7. So if I'm looking at it, 25 better be divisible by 7 if it's going to work. Otherwise, we're in simplest form. So there we are in simplest form. Now, turn it into a decimal. And when I do this, I'm going to go back to my calculator. And I'm going to do 7 divided by 25. And you can see it's going to give us 0.28 as our answer. 0.28. And then if we move it 2 spots to the right to make it a percentage, our last thing we're going to look at is 28%. Okay. So, real quick, one last time, we're going to talk about this mutually exclusive idea. So mutually exclusive means that there's nothing that they share or have in common. Whether the person was born on a Tuesday or a Friday, we can't have any overlaps. We can't have any overlap because they're either born on Tuesday or they're born on Friday. They can't be born on both. So we really have to separate that idea. Okay? Other than that, we're going to pop over and let me show the Discord channel real quick. Please pop in, welcome, be part of it. If you are part of it, react to the rules after you've done reading them, and then pick yourself as a parent or a student. And then you'll have access to anything and everything you want. And if you look, I'm going to go, I had my first student come in my Discord chat. I don't know who this is, but we talked about this and we went through and did these problems kind of through the chat. So not math and not physics. So we're talking about not math and not physics. We're talking about everything outside of what's inside, what they share. So anyways, we kind of chatted through this, but I just want access for anyone to get help that needs it. Okay. And I got quite a few starting to pop in. That's awesome. But please feel free to join and be part of my community. All right. Without further ado, unless there's any questions, I'm good to go, and I can start to post this on YouTube for my students, and they'll be good to go. So for everyone that stopped by, thank you. I appreciate it. Drop a like or a follow if you want, and go ahead and pop over to YouTube and follow, and have a great night.